is lesson 57 for 7th grade, and today we're talking about negative exponents and some scientific notation for small numbers. We've done scientific notation for very large numbers, but we haven't talked about very small numbers yet, and that's actually going to relate to the negative exponents, which we'll talk about first. We've done things with positive exponents so far, but today we're going to talk negative. Alright, so this is something that you'll see on your calculator. For instance, if you type in 0.000001 by 0.00001, and if you type that in, multiply those together, you get a very small number. In fact, this is what the calculator may display, 1 times 10 to the negative 12. Alright, the calculator displayed the product in scientific notation. We want to notice that the exponent is a negative number. So, what we can conclude here is that 1 times 10 to the negative 12th is this very small number right here. And what we're going to find out is that this 12 actually will be 12 place values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so we're going to show you how that happens in a second here. But it's basically like scientific notation as we know it for large numbers, reversed. So let's take a look at this pattern here, which will probably help us see what the negative exponent actually means. Remember that if we have the same base and we're dividing, so 10 to the 5th divided by 10 to the 3rd, we can just subtract these two exponents and we get 10 to the 2nd, which is 100. Or if we write it out, it's 5 tens multiplied together divided by 3 tens multiplied together. So we cross them out, 1 and 1, 1 and 1, 1 and 1. You're left with 10 times 10, which is 100. Alright, now as we go down, so 10 to the 5th becomes 10 to the 4th. This one stays the same. So 10 to the 4th and 10 to the 3rd. If we divide these two, we get 10 to the 1st when we subtract, which is just 10. Let's move further down the line. And we're subtracting the exponent, which I just mentioned. So now if we do 10 to the 3rd divided by 10 to the 3rd, these are all unrelated here. We're just showing you a pattern as this number or exponent decreases. So now we got 3 minus 3, which is 10 to the 0, which is 1. And here's why. Why 10 to the 0 equals 1. Or remember, anything to the 0 power equals 1. It's because it's the same amount over the same amount. When you subtract those exponents, you get 0 and you get 1. So what happens now if we have 10 to the 2nd over 10 to the 3rd? Well, you've got 2 tens up here and 3 down here. So you've got nothing left up here except for 1s. So 1 times 1, and then 1 times 1 times 10. So if we subtract the exponents, 2 minus 3, we get a negative 1. So we can conclude that 10 to the negative 1 is 1 over 10, or 1 over 10 to the 1st power. What happens if we do 10 to the 1st? Well, we've got 1 10 up here. Cross it off with this one. We have 1 over 10 times 10. Or, if we subtract these, 1 minus 3 is negative 2. And we have 1 over 100, or 1 over 10 to the 2nd. So we should be able to notice a pattern here. If we have 10 to the negative 2nd, it's just going to be, we're going to bring this down to the bottom, or the denominator, and it'll turn into a positive exponent. And we have 1 over 10 to the 2nd, or 1 to the 100. 1 and 100, sorry. No, 1 over 100. Messing up my words today. Alright, so if we did 10 to the negative 1, we drop that 10 down here, turn that positive, and we have 1 over 10. And this is the pattern we should notice right here, which we were talking about. Okay, just bring this down to the bottom, and you turn that positive. Bring this down to the bottom, turn that positive. And here is our algebraic expression, or way to show the pattern. Anything to the 0 power is going to be 1. a to the negative n power is going to be 1 over a to the positive n power. So this negative exponent just tells us to drop it down to the denominator and leave 1 on top. And in the future, you might have something like, let's see, 2 times 3 to the negative second. In that case, this comes out, we would leave 2 in the numerator, 3 in the bottom. So 2 over 3 to the second, which is 2 to the 9. We're not going to get into that yet. So for now, our numerator will just stay 1. But that's coming up. Okay. So just to show what we're talking about here, remember anything to the 0 power is 1. So this is going to be just 1 always. Now 3 to the negative second, we will drop that down to the denominator and turn this positive. So we have 1 over 3 to the second, and 3 to the second is 9. So simplified, that would be 1/9. And we'll do the same thing here. Drop this to the bottom, and this turns positive. This equals 10 times 10 times 10, so 1 over 1,000 for that answer right there. Alright, so negative exponent just means that we're dropping it down to the denominator. And we showed you why with those first examples, or that pattern that we saw in the beginning of the lesson. Oops. Alright, so how does this relate to scientific notation? Well, we kind of saw that in the beginning when we had the two very small numbers multiplied together. Like they're saying here. We can show you, so for instance, an inch is 2.54 times 10 to the negative 2 meters. Okay? If we multiply 2.54 by 10 to the negative 10, the product is 0.0254. Alright? So, how do we relate this? Well, we just learned that 10 to the negative 2 is going to be 1 over 10 to the second. So really what this is 2.54 divided by 100. Okay? And when we divide by powers of 10, it moves our decimal over however many spaces we need to go. Well, 2.54 divided by 100 means we're going to move it 2 spots to the left. So it was here 2.54, 1, 2, and that's where we get that from. Okay? We're not going to have to worry about doing this step right here because this negative 2, we're going to find out, just tells us when we're multiplying by power of 10 to move our decimal spot 2 places to the left. So we have to note the sign of the exponent. If the exponent is a positive number, we move the decimal point to the right to express the number in the standard form. So for instance, this number right here, 6.32 times 10 to the 7th, it's a positive 7 for the exponent. So we shift the decimal point 7 places to the right. So we took that right here, moved it 7 places to the right, and we get this number in standard notation. If the exponent is a negative number, we shift the decimal point to the left to write the number in standard form. So this would be the opposite, 6.32 times 10 to the negative 7. So the exponent is negative 7, so that means we're going to shift the point 7 places to the left. Alright, so notice the difference. Positive exponent, shifted 7 to the right. Negative exponent, shifted 7 places to the left. And in either case, we're going to use zeros as placeholders, like we did here. Okay? So that's kind of the difference there. Alright, so let's take a look at a couple here. If we want to write 4.63 times 10 to the negative 8 in standard notation, we first have to look at our exponent. And we should see that it is negative, so we're going to move it 8 spots to the right, or sorry, to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And I didn't draw that very well, I'm going to redo it. Let's put it 4 here more. 4, 6, 3. 8 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8. Decimal point's going to go right there. Fill these with zeros. Right there. So it should be 0.0000000463 in standard notation. So we can start to see where this scientific notation will come in handy because writing this out could get very lengthy, especially when we multiply it with some other numbers. Like we did with the large numbers, we're also going to put this into scientific notation. Scientific notation doesn't change. We still want our first number to be between, or we want it to be less than 10 or equal to 1 or greater. Okay, greater or equal to 1. So what we want to do is get it so that there's only one number to the left of that decimal point. So we want to get that thing right there. 1, 2, 3, 4, 5, 6. Okay, so 3.3 times 10 is not to the positive 6 power, it's to the negative 6 power, because in order to get back to this, we'd have to move to the left. So that's how we would write that. Alright? So there's your answers for those two. Okay? And like always, we'll be spending a pretty good amount of time on this, just to make sure we've got it down. Alright, now let's compare these two. Check my time quick here. Alright, we're doing fine. We want to compare the two numbers 0 and 1 times 10 to the negative third. It's very tempting to say that this number is going to be less than 0, because when we see this negative symbol, we're like, oh, okay, negative number, less than 0. But that's not the case. We have to remember that this only tells us that we're going to shift our decimal place. So we've got 0 over here, and we're just going to let 0 sit there for a little bit, and we'll work with 1 times 10 to the negative third. A couple different ways we could represent this. We know that 10 to the negative third actually means 1 times 1 over 10 to the third. And anything times 1 is just itself, so we can get rid of that. And we actually have 1 over 10 to the third, which is 10 times 10 times 10, or 1 over 1,000. 1/1000. The other thing we could do is, we know that we can write 1 this way, 1.0 times 10 to the third, negative third, and that equals, we just move our decimal 3 spots to the left. 1, 2, 3. So our decimal's there now, fill in the zeros, and we get 0.001. Okay? So no matter which way you look at it, either this way or this way, doesn't matter, both of those fractions or that decimal is bigger than 0. Okay? So we should be eating that way. Eat the bigger number. These are very small numbers, yes, but they're definitely bigger than 0. Alright, and just see how these two relate here. 1 over 1,000, and look at where this, how would we call this or name this number? It's in the thousands place here, so 1/1000. That's why these two are the same. Alright, so that's kind of how they relate there. Alright, so when you have negative exponents, don't assume that you have a negative number, because negative number would have to have been like this. Would have had to have had a negative out front of the big number. Alright, this just means how many spots your decimal is going to move and whether it's going to be left or right. And just a final reminder that your very small numbers may exceed the what your calculator can show you as far as place value, so you might get something like
Todd Nuss and Sasha Jensen to the office, please. Todd Nuss and Sasha Jensen. Also, just a reminder for 7th and 8th grade boys that are in the lifting program, you will test tomorrow morning. Please be here at about 6:15. Thank you.
Alright, sorry about that, but that is all I need to show you today. So we'll talk more about this tomorrow, and we'll spend a couple days at least on it.